So it's week 1 of fall 2017 programming fundamentals, not using Java. So this week we're just going to have the 1 video stream. We won't have 2, and this will be part of our playlist. Okay. So one quick thing I want to mention, I've added this screenshot. If you're installing Visual Studio 2017, when you get to the install screen, it asks you which components you want to install. Now you can install everything. If you have a big hard drive, go ahead. If you don't want to install everything, there are 3 things that we'll need. For this course, we basically just need this. .NET desktop development for building Windows forms. That's what we're going to do in this class. But you probably also want the ASP.NET and Azure development tools, because we're going to be using those next year. So you don't need them for now, but you're going to need them eventually.
I already installed it, so how do I add that stuff?
If you want to go back, the Visual Studio installer is probably still on your machine. So if you just search for Visual Studio installer, that will bring this screen back up and allow you to add or remove components to your current installation. So I think it'll bring it up and you'll have 2 options. It'll say modify or launch underneath your current version. So just click modify and it takes you to this screen where it lets you choose components. So I've just added that little graphic here. 2015, it's a little simpler. They don't really give you this screen if you install the 2015 version. Okay. We can skip over this stuff. We've talked about our book. Okay. Anybody here play an instrument? What do you play, Matt? Guitar. Guitar? Jonathan? Guitar? Anybody else? No one else here plays an instrument?
I play piano.
Piano? Yeah. Okay. How'd the piano sound first time you played it?
Sounded like a lot of fun, actually.
Yeah. And the music you produced, how did that sound the first time you ever played the piano? Bad. How long did you learn? How long would you say it took you to learn to play something sort of recognizable?
About a month.
A month? Okay. How about you guys? How long did it take? Okay, so you were a prodigy. You were a guitar. You were a prodigy.
No,
Yeah, Jonathan. How about you? A couple weeks. Okay. So really, what we're doing in here, it's not something you're just born you know how to do. What we're learning here, it's a skill, right? And like any other skill, to get good at it, you know, how many hours did these people spend doing that stuff to get to the level they're at? Lots. Okay. And some of you are going to pick it up faster than others. That's okay. If the class seems hard at first, it doesn't mean you can't do it. You're not capable. You're in the wrong program. Just means you need to work at it. Okay. So when I do have PowerPoint slides, I'll put them up. I'll put these up on Blackboard. You can take notes if you want. You don't have to. It's not a writing course. So all these slides I'll just post under week 1, and I'll do that every week. Okay. Okay. So we mentioned this stuff already about if you already know the content. Anybody here built their own machine ever? At home? Yeah. Okay. So, you know, understanding this isn't a hardware and networking course. You know, we don't need to know the nuts and bolts of how computers work, but understanding a little bit about how they work actually helps us build better applications. If we understand how the things we build are actually going to run on the machines that. Okay. So, you know, all our computers have these little chips that do our processing, right? We're on Amazon, we want to buy something, we want to check out. There's got to be something processing that transaction. You want to post something on social media, there's got to be some kind of server processor that's going to run that stuff. So very basic stuff. This isn't a math course, you know. We don't require you to know math, but we do have to think about some basic logic and making decisions in things, right? Because we give users two buttons and they click button A or button B. Well, button A's got to do something different than button B, right? So we need to learn how to tell the applications and websites we build what should happen when they click button A versus what should happen when they click button B. So these were actually the first computers. So the first computer was 8 feet tall and 100 feet long. So we've come a long way, right? We're now dealing with computers this size or smaller, right? And this is more powerful than one of those. No matter how complicated computers have gotten and how advanced they've gotten, though, at the end of the day, every application we write, every website, every mobile app you've ever used, it all comes down, all the instructions in there basically boil down to ones and zeros. That's machine language. It's the only thing computers understand. One meaning on and zero meaning off. And all the instructions we give it, like process this credit card, all that code gets translated down to ones and zeros at the end of the day. So basically looks kind of like this. You've heard the terms probably bits and bytes. So a bit is simply a 1 or a 0. Is that switch on or off? And bytes is a set of 8 bits. So often these will represent a character. So for example, we're going to sign up for a website and enter our first name and last name. The way the computer actually stores is going to translate, you know, your name starts with M. It's going to translate that M into a collection of ones and zeros, and that's how it's going to get stored, which is what's known as binary code. So we're not going to work with binary. We use a tool like Visual Studio that we write code. It will automatically convert our stuff to binary so our computers can run it. So this is basically how things get stored. And we obviously still use this measure, right? Any file, if I asked you on your computer, what unit do you use? What unit do we still use to measure sizes of files? Right, bytes, kilobytes or megabytes, right? Which is something we still need to be aware of, we need to know. Maybe we're building a web application where users can upload photos, right? We may need to have a limit on how big those photos are. So we need to say, hey, 5 megabytes max. And we're gonna have to check when they give us a photo, it's not bigger than that. So we can't store anything bigger in bits than 255. And there's our max value. So even sound really is really just broken down all the way down to ones and zeros. That's how we can store audio clips on a computer. It's really all just converted to ones and zeros. Video, pictures, they'd all be the same. So we've got code for this. So that lets us convert numbers and letters into bits, basically, so we can store them. So that's how a computer would store my initials, with that sequences of zeros and ones. If I change one of these, well, it's going to become a different character in that case. And we'll skip over that. So any language, no matter what language we use, we're going to use C#. Programming students are going to use Java. But at the end of the day, any code we write in C#, any code somebody writes in Java, we're going to use these other languages later in some of our other courses. We'll use PHP together next semester. JavaScript in semester 4. They all basically wind up getting boiled down to ones and zeros under the hood. So we need some kind of tool, and the tool we're using in this class is Visual Studio. We need some kind of tool that takes our high-level language that looks kind of similar to English with words we can understand like if, print, and has those kinds of commands, exit. And we need some kind of compiler to translate all that stuff into ones and zeros. So in our case, we're going to use Visual Studio. So when we write languages, one thing we're going to see a lot of is what are called syntax errors. So syntax means when we don't follow the rules of the language. So in written language, a syntax error would be this. What's missing from this? Comma or period or a semicolon, right? So what would be a grammatical error in English? In computer language, this would be a syntax error. Every command we write in C#, rather than having a period at the end, we're going to have this. Commands in many languages, like Java, C#, PHP, they end with a semicolon. So if we write a command, like print, and we don't end it with a semicolon, we're going to get a syntax error and our program's going to crash. We're going to get an error. One of the nice things about using a tool like Visual Studio, it will highlight all our errors. So if we leave this out, it's going to put a little red line here at the end of the command saying, hey, you forgot something. And it actually won't even let our program run until we fix all of the language problems we have, which is great. It points out our typos or anything else it doesn't recognize. So the reason we're gonna use C# for a few reasons. It's really well structured. It's been around for quite a while. It's quite a mature language, and it's relatively easy to learn. And the good thing about all the languages you're going to learn through the program here is they're all based on the original programming language called C. So Java is based on C, PHP is based on C, C# is based on C, JavaScript. So the good news is all those languages look very similar. You're not learning one language that, for example, looks like Korean characters, and another language that looks like Russian characters, another looks like English. So they all will look similar, so it's really easy to start to move from one to the other. So how do we actually plan this stuff? Particularly when we're learning, but even once we're experienced developers, it's not usually just a case of somebody asks us to build something, we sit down and do it. Right? Think about if you were going to get a house built. What would the first thing do? What would the first thing you do? You go and you buy a lot, buy an empty lot, you want to have somebody build a house for you. Yeah, right. You're going to have somebody design what that house looks like, right? You don't want the builders showing up with their trucks and tools and standing on your lot and saying, okay, how big is the house going to be? Where's the door going to be? How many windows? Is it brick? Is it siding? You're going to plan all that stuff out ahead of time. It's really the same thing when we're building applications. We kind of do it in two steps. First, figure out what are we building? How does it work? And then we take that plan and we build it. I can show you a real world example of this because I'm involved with a project at the Research and Innovation Center. We have a co-op student and he's building a web application for a local not-for-profit. And I'm involved in kind of mentoring him. He's doing the work, but I'm guiding him. So he's starting, he hasn't written any code yet. He hasn't even decided what language he's going to use. Although he's probably going to use C#, I suspect. So there's two parts to our planning. I can actually show you these. So we created this Excel file. This is kind of step one. So he's laying out who are all the people that are going to use this application, what are all of the things they can do, and how are we going to know when that feature is actually working and finished? How can we say it's done or it isn't done so that our client can sign off and approve it? And then he's also saying, is it high priority, medium, or low, and how big is this task? Will it take me half a day, multiple days to do? So he's not writing any code until he finishes it. He's been spending days on this. He just sent me an email on the break and said, I'm nearly done. Can you have a look? And go. So this is step one of the plan. And we'll work together on this. This is step two of the plan. Again, even before he writes any code. We then post all this stuff online for our client to see. And we've broken the project up into 2 weeks at a time. So he's going to put all of these tasks online, and then put each one into a phase of the project so he knows exactly what order he's going to do all the work in. And we can keep track of his progress. Right? So it seems like a lot of extra work before he actually gets to go do anything. But what that means is once he starts building, all the decisions we've already made. He's got a plan and he can just stick to it. If he can't finish the job or it's too much work for him, we could hire somebody else. They could just follow the plan, right? Because we've laid it all out. So just like you would build a house that way, we kind of plan our applications like this, even the simplest ones. So we use a few tools for this when we're starting. One of them we continually use is charts. We visually map out what happens in this program, right? What happens if a user checking out gives us an invalid credit card? What do we do? Well, the easiest way to plan it for many cases, draw a diagram. Yes. If something else happens, go there and we can see it. That helps a lot of people, especially if we're visual. We also have this tool which we'll play around with called pseudocode. Pseudocode basically means, has anybody heard this term before? Yeah. What's pseudocode?
It's kind of like writing down what your code is supposed to do or like translating it.
Yeah, we just write out the steps in English, English the language, without writing any code. We write a series of the steps that lets us plan out everything that will happen. And then we can write the actual code instructions underneath. So that's a good way for us to start to think about one step at a time, what happens in this application? How's someone going to use it? Then we write the code, we check for any errors. Then we check for logic errors. So we have to test it. It's working with no errors, but does it do the things we want it to do? Right? If I check out, does it actually charge my credit card? Or does it not? And then lastly, we have some tools for this. Every website we ever build, there's going to be time for debugging. Every time, right? No company writes perfect software, not even the best, biggest companies in the world, right? That's why they're giving you updates and patches, because they find bugs and then they're sending you fixes. What percentage of our time do you think is spent debugging? So if we build a website, let's say it takes us 100 hours to build that website, to design it, plan it, write all the code, do all the layout design, get it all working. If it's 100 hours, how much extra time do you think we're going to spend just finding and fixing the errors? More than 100? You say? Okay. What do you think? Yep. Okay. Anybody else want to venture an opinion?
Depending on the project, you might have the same practice like from scratch.
You might. We certainly hope not. Right? That's a good way to burn through our clients' money or our own money pretty fast. So if we spend 100 hours building, how many hours will you spend debugging? What do you think?
15-20%.
Yeah, that's probably a decent guess.
I don't think you'd ever stop because you want to keep on updating it, right?
Yeah, ideally you would. But I mean, to the point where we can say, okay, it's ready. Right?
About half the time.
Could be half. So maybe 50 hours of debugging for 100 hours. What's typical is probably in the range of about 30%. So it's going to take me 100 hours to build it. I'm going to need probably somewhere in the neighborhood of another 25 to 40 hours to test it, find it, fix all the bugs. So we have to keep that in mind. If we have a client and our client says, how long is this going to take and how much it's going to cost? Well, it's not just the 100 hours you're building, it's the 30 hours of fixing. Or if your boss says, hey, how much time do you need to do this? Right? It's not just how much time we need to do it, it's also how much time we need to find and fix the problems. So that kind of comes, it's part of the job. So we'll look at some tools and some ways, how do we get good at finding and fixing bugs? It's really easy to fix someone else's bugs. It's really hard to fix your own. So our process, it kind of looks like this. So the more thorough job we can do planning, build stuff that actually works the way it's supposed to. So there's really two steps for this. The first one is just learning what are we building? You know, what does our customer want? Or if we're working in a big organization and someone's paying us to build something, what is it supposed to do? How is it supposed to work? So typically what happens in that case is we have a meeting with whoever's paying for the job, often it's our client, and we sit down and we get them as best we can to tell us what it is that they want. And we ask lots of questions. trying to get an understanding of what does this thing look like? What is it supposed to do? So that's what we did, even in the case of this project. They have an office near here. So last week, my co-op student and I, we went over there and we talked to them about, hey, what is it you want? And they actually don't have a current website. They have all this whole system on paper and on CDs. And they showed us their papers and they said, all this stuff we're doing on paper, we want it all as a website that people can go there, and people don't have to do this stuff on paper. They can do it online, on a computer, on a tablet, on a phone. So that helps when they have that stuff. Then we try breaking it down into all these little tasks. That's what my little Excel file was for. So my student doesn't get overwhelmed what he's supposed to do. He can figure out one piece at a time what he's doing. So we can also do it something like visually. So here, for example, we've got a payroll calculator. We're going to start. Our program will ask, figure out how many hours did this employee work. We'll get them to enter how much they get paid an hour. Then we're going to do some kind of calculation. And then our program is going to spit out something back, right? How much money are we supposed to pay that person? So all programming, all websites, I know probably most of you don't think of websites this way. All they really do is this. We get some inputs, we do some processing, and we have some outputs. Okay. So everything we do, it's kind of in this cycle. We ask users for information, we take that information, we store it, we manipulate it, we do things with it, and then we give information back to users. Maybe different information. So we might display things. So here's another simple example. We're asking somebody how old they are, and then we're just spitting that value back out to them. Usually our outputs are a little more complicated than that. It's the world's simplest example. And we're going to hear this term a lot. Today's the last day of your life. You will not know what this word means. We're going to use the word variable every class. So usually when we get information from someone using our application or our website, we store those in what we call variables. So for example, it might be a sign-up form on a website where we have a first name box and a last name box, username, password. So we're going to store the 4 values somebody enters as 4 different variables. Why do you suppose those are called variables? Yeah, because the values of each of them will be different, right? My first name is different from your first name. We both have a first name, but the value of those things are different. And they might change, right? Our variable might be, if we're on Amazon, the variable might be the current cost of our shopping cart. So I've got one item in my cart's worth $20. Put a second item in, that cart value has gone from $20 to $40 maybe. So that's how we keep track of the inputs that we're getting from our users. And those inputs don't have to be text. What other kinds of inputs, especially think about websites, what else? So giving users boxes to type in, that's one way we can get information from our users. What other ways can we get information from our users? Yeah, they could check a box with a click. Yeah, think of a Facebook photo album, right? Your photos, all your media, those are inputs, right? You as the end user are providing information to the application, which it's going to store. Sometimes the inputs might just be clicking a button, right? Choice A or choice B. You're telling the application, you're giving it an input so it can do something. I want to see this one. So we've got a few rules around creating variables. We'll get into this again. I'll review it next week. One of the important rules is we can't have any spaces in them. So if we're going to ask someone for their first name, there's a few ways we can do this. We can store it like this. That's okay. What's very common would be this. This is called camel case. So we have a variable with multiple words. to make those multiple words readable, we capitalize not the first word, but all the subsequent words. So this is allowed, this is allowed, this isn't allowed. First name. Our programming language is going to consider these two separate things if you put a space in. So one of the habits we'll get out of is whenever we create names for anything, even web page names, we don't want spaces in them. I create things without a space. And typically we give them descriptive names. So we don't want to have variables called X, Y, and Z, or variable 1, variable 2, variable 3, because they make it hard to understand what those things mean. We want to have first name, last name, username, password. So let's think about some of the web applications we use every day. We talked about one example already. So we said something like photos, your photos on Facebook, that's an example of an input. What other kinds of inputs do we give as Facebook users?
Personal information, just like checking off boxes like male, female, your relationship status.
Yep, so everything to do with your own profile, every one of those is another input, right? What does Facebook do with each one of those values?
Target ads towards your things that you click.
Yeah, okay, but even before that, where do they go, right? So I'm going to create a new Facebook profile, or I'm going to update my profile now, right? I wasn't single, now I am, so I'm telling Facebook, right? What do they do with that information? Yeah, they process it, and where does it go?
On your profile.
Yeah, so it goes on your profile. Where does it get actually saved? Where does Facebook store it? Yeah, where in the server? You're right. Right, Facebook has a database that holds every input anybody ever gives them, right? A photo, all your profile information. So the processing, we give them profile information, Facebook processes it, and they save it in the Facebook database, right? So one of the outputs, you're absolutely right, is ads that they target based on the inputs we give them, right? So that's one example. What other kinds of inputs do we give Facebook besides our profile and our photos? Sorry? Status updates, yep.
Images?
Yeah, our images.
Content that we like.
Yeah, so what things you like. Every time you click the like button, you're giving Facebook an input, right? And they're storing that so they know what you like. So they can show you ads to sell you stuff and Facebook can make money.
They will store when you search someone. It's going to store the person you search.
Yeah, it stores your search. So if we search something, it's going to, Facebook stores it, right? Because if you start typing in the search bar, it brings up all your old searches. So it considers those inputs. What else would be inputs?
Location.
Yeah, if you turn it on, where you are is an input. Yeah, absolutely, right? How does it know who your friends are? Right? When you send a friend request, you're giving Facebook an input. I'm making a request to this profile. And when you get a request, you're also providing an input, right? I accept that. Or if you accept the friend request, that person's added, you're added to each other's lists. So again, Facebook's storing that information.
It might be a stretch, but I don't have Facebook, but I think based on who you have a mutual relationship with, like let's say you add a friend, they might take a guess as to the fact that you might actually know somebody that both.
Absolutely.
Friend that you've added. No.
Absolutely. So this is
Oh, fine friend, yeah.
this is my bogus Facebook profile. Most of you, I think all of you are too young to know who this is. So this was a TV character from the 70s. So I just use this profile for teaching because we talk about Facebook a lot. It's an app most of you are familiar with, and it illustrates a lot of the stuff I want you guys to learn. So we look at it a lot. So all of these people you may know are people who we are not connected on Facebook, but we have mutual friends, right? Most of these people are students. A lot of these people were students here. Okay. So that's an output Facebook generates to us. So Facebook has no content of its own, nothing, right? All the content, everything on here that we see is generated by the users. Now, there's no shame in admitting this. Who uses Facebook, looks at Facebook more than once a day? Okay. Why? Sorry? Okay. So how might Facebook alleviate your boredom? Okay. Just scratching your head.
So you can connect with like all your friends that maybe not be in your city or not even near you.
Okay. But if you check it, if you're one of those people who checks it all the time, why do you check it all the time? What do you hope to see each time you come back? Something new, right? You want to see inputs that are new, presumably from your friends, right? If people weren't giving Facebook new inputs all the time, you wouldn't check it all the time if it never changed. You come here because people are constantly giving new inputs and you want to see them as outputs. So what's an input for you on Facebook is an output for everybody in your network, right? We're providing each other with content all the time. That's why we come here. So the processing that Facebook does is basically store everything users give us in a database and then make it available for everybody in their network, and best for Facebook's business model, show that user ads. So the more personal information Facebook can, the more you give it, the more money they can make targeting ads to you. That's the whole business model, right? That's why it's free. They're selling your personal information to advertisers. That's how it works. While we're on the subject of Facebook, Scott may or may not have mentioned this, but we do have a Facebook group here. Scott manages the group, so you can request access. It's the Georgian College Web Design and Development. We haven't changed the name. It's a good place to go because there are lots of things that get posted here. So we'll post so events at the college. If I read any kind of relevant articles, so here was one that was in Saturday's Globe and Mail about co-op programs and companies doing class project, companies giving projects in class. Kind of an interesting article. So we post this kind of stuff, but also if there's any new tools or things like that, you can post on here. So a lot of students will post. And Scott and I, if we, co-ops typically go through Jody, but oftentimes employers will just contact Scott or me directly because we have lots of contacts. We've worked in this industry for a long time. So if a job happens or a contract opportunity comes into us, we'll post it here. And also many of our former students are on here. So it's actually a way to connect with people who've been through the program before and are working in the industry. So if you are a Facebook user, you may want to send a join request to Scott for the group. There's often useful things here. And I often learn awesome stuff from students. Students find cool tools or things, they'll post them on here. That was one example. This is probably the first site I go to every day, roll out of bed, grab my phone, make sure there's no pressing email, make myself something to drink, and I'm going to read the paper online. So what kinds of inputs would this application have? What things are going in here? Yeah, okay, so news and articles. Videos. Yep, you can provide your own feedback. Right? You can add comments. Anything else? Absolutely. So we go here. Right? I can subscribe through their website. Which doesn't seem to be, oh, just a little slow, right? So I can register or subscribe. So I can register so I can make comments on the articles without buying the paper, or I can create a subscription account and pay for it. I can do either one of these, right? So all these things are inputs. What kinds of processing would this application do? So what'll happen, for example, when a user goes to the subscribe page, fills it out, presses the subscribe now button at the bottom. Yeah, it's going to store their information in their database. What else might happen if I'm subscribing, which is a paid service? Yeah, it's got to process my payment. I can take my credit card and process my payment. Yep.
It'll send out like a newsletter, like an email maybe.
Yep, probably send me a confirmation. May have things I can sign up and subscribe to, right? If you're an investor, you can go into the investor section and subscribe to get to watch the stocks in your portfolio, and it'll send you notifications.
You might be able to receive personalized articles based on things that you might be interested in.
Yep.
Like if you're only interested in environmental happenings in berries, then it'll send you if something goes around.
Yep.
Happens in berries.
And like Facebook, the ads might get targeted as well, right? If they see I click on the sports section every day, probably it's going to start advertising $800 Leaf tickets for me on the side. What about the outputs? What kinds of things come out of it? Those are the inputs. Yeah, so for us as the end user, the articles are an output. For the Globe and Mail, the company, the articles are the inputs, right? They put them in and we view them. What other things do we view?
Sorry, one of the outputs would be how many people have viewed a certain article?
Yeah, in fact, we should see that. We can probably see that with any article. So all of the things here, images, it may tell us how many people have viewed it. It certainly will tell the Globe and Mail how many people have viewed it, but the comments become outputs, right? We can see how many people have commented on here, related articles, all the ads. So it's really the same structure: inputs, processing, outputs. What about here? What kinds of inputs would we have on Amazon?
Products.
Okay, so for Amazon, yeah, they're going to input their product catalog. Yeah, we can input reviews. Yep, same thing. We can create customer accounts. We can make payments. We can make orders. What about the processing? What kinds of processing is Amazon doing?
Gift cards?
Yeah, could you gift cards?
Not calculating, right? Advertising.
Absolutely, right? There's a, they feature certain things on the front page. How do they figure that out? Well, based on their processing, what are their best sellers? For example, there's millions of products. They must have a way of deciding. It's not random what they put on the front page, right? There's some thought going into that. So on virtually every website, the top of it is pretty much the same on all the pages, right? No matter where I go. We've got some kind of header and some kind of footer, and obviously we'll learn how to design and build those. But in between, almost all the other content is some kind of output. It was input. In Facebook's case, it was input by the users. In the Globe and Mail and Amazon's case, they control most of the inputs, but we come to the site to see the outputs, right? To see the products, to see the news, etc. So you see this same structure of header at the top, footer at the bottom, and a whole bunch of dynamic output. And that's why websites want to constantly give us new outputs. Otherwise, we won't come back, right? If the website's the same every day, you're going to come once, you're probably not going to keep coming back. But they want us to come back, so they've got to give us new stuff all the time. It all follows this model. So in this class, what we're going to do is build a whole bunch of little programs to kind of get used to this flow. How do we ask users? Like, how do we build a sign-up form? And then how do we process that? Or how do we build a mini shopping cart? Or they can pick their products, and then we can calculate how much is their order, what's the tax, what's the shipping going to be, and we can tell them, hey, here's how much your order is going to be, and display that as an output back to our user. Okay. So here's what I want you to do. 5 minutes is enough time. So think of some other either website or even a mobile app that you use often. Okay. And I want you to make 3 lists. What are some of the inputs that this application takes in from the users? What is some of the processing that application does? And what are some of the outputs? So see if you can come up with at least 2 or 3 in each category. Just pick one site or one app that you use regularly. Not Facebook, not Globe and Mail, not Amazon. Okay? Take 5 minutes, just make a little list. You can scribble it down, make a note on your computer. Okay, I'm going to ask you to pause there. Anybody have a site we could have a quick look at? Sorry? .com? Got the right URL? Okay, so what would you say are some of the inputs, processing and output that happens here?
So some of the inputs, so it's what it is, it's a website that keeps track of like your record collection.
Okay.
Has a marketplace and all that stuff.
Yep.
Some of the inputs would be information for any records that you want to add into your collection.
Yep.
Marketplace info for your collection, so how much it would cost, what the retail value is.
Okay.
Things like that. It would be credit card information when you're planning on
Yep.
buying and selling. And profile updates, so here also would be like your email address, password.
Okay. So what sort of processing happens on here?
So it would run credit card payments.
Okay.
In the marketplace. You would save searches depending on.
Yep.
So like similar to Facebook friends, it would be like some albums you may be interested in.
Okay, and what about some of the outputs?
Some of the I ain't got that for yet.
Okay.
You stopped me too early.
Sorry about that.
But I think it would be much the same as the inputs, just viewing it with it. rather
Right,
than the-
okay. All right, somebody else have another site we could pull up? Okay, so what would be some of the inputs, some of the outputs, some of the processing here?
Users basically saying very financial and other users comments on that.
Okay,
They might download or upload them, or you can register as well. To sign up. Some of the content are generated by bots. Also, bots can also output. For instance, you can type like reminds me, and then
Yep.
will output. And also, it's gonna obviously store the information on database, and when the time is what you want to remind you.
Yep.
And it's gonna show up on your mailbox.
okay, great. Anybody else want to suggest another site we could have a look at?
Drivebomb.com. So video game website, so basically some of the inputs are the message board, the Wikipedia database that they have, a premium account for other content.
Mhm.
Some of the processing is PayPal, stuff like that.
Yep.
Set up your account, your login. The output is the actual content itself, so whether it's podcasts, let's plays, live streams, that kind of stuff.
Okay. Anybody else want to suggest another one?
Uber as an application.
Yeah, okay, we won't be able to see it in the browser because it's just going to prompt me to download it. But yeah, what are some of the inputs, the outputs, and the processing with Uber?
Yeah, so you got location, your location, the time from pickup, the amount of users using it at the same time, the drivers on the road, the locations of those drivers, traffic updates, how often you use Uber, your payment methods, personal information, road closures, the driver's contact information, support info just in case something goes wrong,
Mhm.
and your kind of vehicle needs. Processing after that would be the location from you and the driver,
Yep.
so where you need to go, as well as time and distance, as well as taking into account traffic and users using it, and your driver's distance. Let's say you use Uber Pool, then others drop-off locations, and an estimate of the rate, rating all those things. Output would be time and distance given and a rate offered based on that algorithm, and the driver's closest to you and the type of car that they're going to be bringing.
Yep. So in that little tiny app, it's doing all of that stuff,
Yeah.
right? It's a lot of features. Anybody else have another suggestion we can look at? Okay.
Some of the stuff would be like, creating your account, things with information, for example, like Facebook.
Yep.
To, create your stuff. You would save some of your, kind of put some of your information on Facebook.
Mhm.
Have that. You can also,
Yep.
And so it would be like, it says who, like, it says who you send your often to. So
Right.
like, well,
Okay. So the reason I wanted to look at a whole bunch and have you think about this was to kind of give you the sense that every application you use every day, whether it's a native mobile app or a website, they all work the same way. They all have this same model. Some stuff comes in, some stuff comes out, and there's work done in the middle somewhere in the back end of the code in order to take those inputs and show people whatever it is they want, whether it's the closest driver, your friends, your biggest streaks, or whatever it is. So the idea really is all this kind of model, it's independent of whatever language or technology or platform we're using. So once we understand how to put a program together with inputs, outputs, and processing in the middle, should be able to build pretty much any kind of application that we get asked to build. Because the tools, the languages we teach you here, they all become obsolete down the road. This is probably, there's no industry that changes faster than this one. So whatever we teach you today, 5 years from now, you probably will use very few of these tools. But if you understand the process, well, you can just go ahead and learn a new language. You're still going to be processing, building your applications in the same way. Okay. So let's plan out, we'll kind of draw out one very simple application, and then we're done for the day. A little 5-minute task. So we had talked about how to plan this stuff out, and that we had a few tools. So one of them was pseudocode, writing out the steps, and one of them was a flowchart, a little visual tool. So there are some free tools online that let us draw and save these kinds of diagrams. So we're going to give you like the world's simplest program. We'll write out the pseudocode, which will basically be about 3 lines, and then we'll draw a little diagram using a free online tool. And then it's the weekend, all right? So here's what we're going to build. Actually, I'll just do it all right on Blackboard. You don't have to take notes on this. I'll just record as we're talking about it, and I'll save it into the week 1 folder. Okay. So we want So what we want to do is take an input, take a numeric value. We're going to ask our user to give that to us. They provide a value. Maybe it's, the bill in the restaurant or their charge at a store, the amount of stuff they bought. We want to take that value and we want to calculate how much tax there will be. HST, 13%, Canada. And then what the total amount is total amount of money they're going to have to spend. So we're going to have one input, which is the amount of their sale, the amount of their purchase. We're going to have 2 outputs, right? We need to calculate how much is the tax and what's the other output going to be. Or we basically add those 2 together. So we'll just do this. I'll just do this as a simple bulleted list. So let's write out the steps we would need in order to do that. What would be the first thing our program needs to do? Yeah, so sorry if this is a bit small. So the first thing is we're going to ask our user to put in how much did they spend. So that's an input our user is going to give our program. What's the second thing we're going to do once we know how much they spent? Yes, but we'll keep it even simpler. We'll say there's no tip. It's just the raw tax. So let's say we're shopping in a store rather than in a restaurant or bar where there's a tip. So we could, but that's just an extra step we'll just leave out for today. We're not even going to worry about that. We don't care about how they're paying. We've got an input. We're going to calculate the tax amount. So we're going to do some processing with that input. How much tax is that going to be? Once we calculated out how much tax they owe, what would the next thing we're going to do?
original order code?
Yeah, so we'll add the tax amount to the original total. Okay, so 2 processing steps. 1 multiplication equation, 1 simple addition equation. What would we do next? We get 2 more steps and our program's done.
We can output both the tax amount as a separate line.
Yep.
And output the total as a separate line.
That's it. So even without knowing what language we were going to use or whether this is you know, an iOS app or a web application, that's our process. So by mapping it out step by step, it's going to make writing the code easier because now we actually know all the things we're going to need to do. So when we write our programs, typically what we'll do in class is we'll lay out in pseudocode everything we're going to do first. So we know everyone's clear on what the steps are, and then we'll write the code and try and get it to work. This is also really helpful for one other reason. So I'll just save that. We can see it here. In here, so here's my code in Visual Studio. So most of my code is in black and in blue, but there's a few lines of code that are in green. Why do you suppose those lines are in green? Yeah, they're comments or description of what we're doing. So whenever we write code in any language, it's always a good idea to put comments in for a couple of reasons. Why are comments smart? Yeah, it can get really complicated sometimes. We're doing things that are complex. Yep. Yeah, often we're working with other people. So it's much easier. It's hard to work with other people's code. If they've commented it or documented, it's easier for us to follow. And many times, Brandon, you mentioned we confuse ourselves, particularly like this application. I wrote this 11 years ago. I don't remember what they asked me to do 11 years ago. So these comments are for me. So one of the other nice things about pseudocode is we can now use this as the comments in our program. So we plan it out, the steps, but then we'll take those and paste them into Visual Studio, and those are our steps. And then we can write in the individual code down below. Okay. So whenever I give you assignments, you get marks for adding comments to your code because it's good practice. And I always put comments in my code for the reasons we just. So in your browser, open up a new tab. Here's a great free tool for drawing all kinds of diagrams called draw.io. You can use it for flowcharts, but you can use it to draw pretty much any kind of diagram. And then we have the ability, it asks me to save, I'll just say decide later, but you can integrate it with your Google Drive, OneDrive, Dropbox, etc. So we'll automatically save any diagrams you do there, which is kind of cool. I'm not going to worry about that. Just say decide later. So there's all kinds of different templates here. This entity relation, you'll use that next semester when you guys start building databases, doing database diagrams. So we just want the basic flow chart. So we're going to plan out visually what we have here. So the first symbol for a flow chart is usually this one, this ellipse. If I just click and drag it on, it'll draw a circle, and if I type, it'll say start. But usually we have that use that ellipse shape with a flow chart as a start and as a finish. So we have one at the top and one at the bottom. Then if I grab one of these, it doesn't really matter what symbol you use, but there's sort of some conventions. I'll grab this second one, this rounded rectangle. Drag it on, and we'll say, ask for order amount. We've got an input. So that shape indicates we're getting some kind of information from whoever using the application. We can connect these up. If I just click on this little point here and drag it down, draws a little arrow. So start here, then go here. Then I'm going to use this one, usually this parallelogram shape we use for processing. So I'll drag one of those on. We're going to calculate the tax amount. And again, I'll just draw a little line. Again, I'm recording all this on YouTube, so if it's going a bit fast, no problem. You can go watch it again. Then we're going to do more processing, so I'll drag another one of those on. Calculate the total amount. I'll connect those up. So we've gotten our one input. We've done our 2 steps of processing. Now we just need our 2 outputs. So we use a different symbol. I think it's this one. Well, it says document, but we can use it for displaying data. The other symbol here we use a lot of is this diamond. The diamond is a decision. So did this happen or did that happen? If this happens, do this. If the other thing happens, do that. For example, is the user's login valid? Yes or no? So now we'll just take this document. So now we'll display tax amount. Connect those up. And we'll display the total. And then we'll just put another one of those ellipses at the end to indicate our program's finished. Doesn't have to do anything else. So I'll drag one more of those and type end. So some people prefer this style of planning things out because they can actually see the execution where what's going to happen. Other people prefer the pseudocode version. For getting started, we're going to use both of these quite a lot. Because whichever way, hopefully one or both of these help you start to think really 2 things in terms of input, processing, and output, and also in terms of the flow, what happens when a user does this, what happens next? And what are we supposed to calculate or process, and what should we show the user? What do they want to see? So there's our little flow chart. I can save this, so I'll just save this and I'll put it up on Blackboard. If I save it on my device, no, I don't want it that way. Export as, I'll save it as a PNG file. I'll save it as an image. And I'll call it tax calculator chart. So I'll save that and I'll also upload it to Blackboard. Okay, if you don't have the exact diagram, that's fine. You can play around with this website. It's free to use. So I'll upload that here. So there are plenty of other tools you could use for doing flowcharts. You may just prefer to hand draw them, but they're a good tool, especially when we're starting out. Until this thinking, it'll take a while for this sort of thinking to become second nature for some people.
So you have different shapes representing different things, like, you know, the circle represents data.
Yes.
The wavy one is like decisions.
Yeah, so that's part, we use the different shapes so you can tell whether it's an input, an output, a decision, or processing.
Right, just for shapes, just because we're not used to it yet, is there something we can look up that lets us know which one stands for what?
Good question. And I'm not entirely sure I used all of the standards. Google is our best friend.
If we hack to vary, can we just make like a legend?
Yeah.
Yep, you could do that. Okay, yeah, so here's their standard. So decision is a diamond. Here, let's see. So so the processing, okay, I did it as a parallelogram. I guess it's actually a rectangle. That's the decision. They didn't.
What would be an example of like a document? Like for something that we use, what would be an example of a document?
Well, something like in a Facebook photo album, right? You're actually seeing all the images are documents, right? Because they're physical files stored on a file system. So those would be documents. Or a list of PDF, like a website that had newsletters, and each one was in a PDF, those would be documents.
Oh. And sub-process, I'm
Sorry?
sorry. Sub-process?
So that would be something happens underneath this one. So maybe the process is checkout. A sub-process might be validate credit card.
Oh, okay.
Right? So part of a process that's part of an overall larger process. So, or for example, even in our little example, we could have had a process called calculate order total, which would include the sub-processes of first the tax and then the overall total. Maybe we have a calculate shipping amount or a calculate tip, as you mentioned, in there as well. So those are mini processes that are part of a larger one. So yeah, I guess I could modify my symbols a little bit. So if you're a visual learner, you'll probably find the flow charting really kind of helps with this process. Helps some people, not others. We'll use both of these tools, at least for a while. Okay, I think our time is about up. So I'll set you guys free for the day. So your only homework between now and next week is to come to class next week with Visual Studio running so that we can start playing around with it and building some application with C#. Other than that, have a great weekend. I do have office hours next week. If you do need some help, you can come to office hours next week.